So here is another question on simple harmonic motion. So it is given that for a particle executing SHM, simple harmonic motion, the displacement x of the particle as a function of time t is given as x is equal to capital A sine 2 pi t, where x is in centimeters and t is in second. Then it is given that let the time taken by the particle to travel from x is equal to 0 to x is equal to a by 2, which means half of its amplitude. Okay, so the time taken to travel from x is equal to 0 to x is equal to a by 2 be t1, and the time taken to travel from x is equal to a by 2 to x is equal to a, that is the remaining half, be t2. So we have to find the ratio of these two, durations, time durations. Okay, so first, the basic format of simple harmonic motion. Okay, x is equal to a sine omega t plus phi. We will compare it with the given function, which is a sine 2 pi t. So here amplitude is equal to a, omega is angular frequency is 2 pi radians per second, it is a centimeters, and the initial phase angle is 0 radians per second. Okay, so let us try to understand this thing. So it is given that this particle, it executes simple harmonic motion. Let these be the two extreme points PQ and this O be the equilibrium position. So initial phase angle is 0, it means it starts from this point, equilibrium position. This is A, amplitude on one extreme or one side. So here it is given that to travel from 0 to a by 2, here it is x is equal to 0, here it is x is equal to a by 2. This much distance it is covered in time, let's say t1, and the remaining from here to here, let this distance, the remaining, it is covered in time t2. Okay, this is a by 2 and this is a finally, and this is 0. So we have to find the ratio between t1 and t2. Okay, so we will make some substitutions in this given equation. So at time t equals to t1, the particle has reached half of its amplitude, so x is equal to a by 2. So if we substitute it here by substituting t with t1, so a by 2 is equal to a sine 2 pi t1. Okay, at t1, t equals to t1, x is equal to a by 2. That implies 1 by 2, bringing a on this side, a by 2 by a, that is 1 by 2, that is equal to sine 2 pi t1. So in order to equate LHS with RHS, we have to come up with some function whose value is equal to 1 by 2. So sine 30 degree in terms of radians, it is sine pi by 6. So that implies sine 2 pi t1, in place of 1 by 2 I am writing sine pi by 6. Okay, because sine pi by 6 is 1 by 2. So that implies 2 pi t1 is equal to pi by 6. So pi gets cancelled. So t1 is equal to 1 by 12 seconds. t1 is equal to 1 by 12 seconds. Okay, t1 is equal to 1 by 12 seconds. So we have got this. Now the remaining, so we will calculate it indirectly. So let's say to travel from x is equal to 0, okay, x is equal to 0 to x is equal to a, from here to here, the entire, right half, the right extreme, let the total time taken be t subscript t. That is the total time to travel from x is equal to 0 to x is equal to plus a. So if we make the substitutions at t is equal to total time t subscript t, x is equal to a. Okay, again I am repeating, let time t subscript t be taken for the particle to travel from x is equal to 0 to x is equal to a, towards the right, plus a. So it means that t equals to tt, x is equal to a. So if we make the substitutions, it will be a, that is x is equal to a, that is equal to a sine 2 pi t subscript t. Okay, this. So here so it is a sine 2 pi t subscript t. That implies sine 2 pi t subscript t is equal to a by a, that is equal to 1. Now in order to equate both these functions, we have to come up with a sine function whose value is equal to 1. So that is sine 90 degree or sine pi by 2. That implies sine 2 pi tt is equal to sine pi by 2. That implies 2 pi t subscript t is equal to pi by 2. Okay, pi gets cancelled, so that implies t subscript t is equal to 1 by 4 seconds. Okay, now the important thing here, t subscript t is the time taken, the total time taken to travel from x is equal to 0 to x is equal to a. Okay, in between there is a by 2 also. Okay, that is 1 by 4 seconds. Now t1 is the time taken to travel from x is equal to 0 to x is equal to a by 2. That is, we have calculated 1 by 12 seconds. Now from x is equal to a by 2 to x is equal to a, that is equal to t2. This is equal to t subscript t, the total time. This is equal to t1. So total time t subscript t, that is equal to t1 plus t2. That implies t2 is equal to the total time t subscript t minus t1, which is equal to 1 by 4 minus 1 by 12. Okay, 1 by 4 minus 1 by 12. So it is coming 3 minus 1, which is equal to 2 by 12. So that is equal to 1 by 6 seconds, t2. t2 is equal to 1 by 6 seconds. So now the ratio of t1 by t2, that is equal to 1 by 12 by 1 by 6. Okay, that is equal to how much? It is coming 1 by 12, 1 by 2. Okay, the ratio between T1 and T2, T1 by T2 is equal to 1 by 2. This is the ratio. Okay, so this is the thing. So a very good question related to SHM displacement equation, and we had to find the ratio of two time durations to cover, you know, two separate displacements in the same side. Okay,